Hello, everyone. Welcome to the webinar today. My name is Eli Matthews, Principal Solutions Engineer here at Logz.io. Joining with me on staff today is Ido Halevi. He's Integrations Product Manager, doing a component of the presentation. Also, we have Eric Alfano from the Tech Ops organization doing a portion of the presentation as well. We're going to be taking questions at the end and answering them. Feel free to post any of your questions in the chat in the meantime, and then we'll get to them at the end of the presentation. So today we'll be talking about containers, orchestration, monitoring, and logging. So let's go ahead and get started. As I said, I'm Eli Matthews, Solutions Architect, been here at Logz.io for going on just about 3 years, and there's my email address if you'd like to post any questions, follow up to me as well. So just to set an agenda of what we're going to talk about today, I'm going to talk about some of the common container metadata that we're looking to get into Logz.io or into any log aggregation solution. And then we're going to talk about Amazon's Elastic Container Service and some specialty logging solutions there. Eric's going to cover how we log containers at Logz.io internally, just to give you an idea of some different ways to log that information and how we do it here. Ido will help cover the Kubernetes component and what our logging solution is, what our best practice recommendation is for that. And then finally, I'll be following up with some comparison charts of the different solutions and ways to log, as well as some best practices that we've noticed in the field and discussing with our customers. So there's me tossing my son in the air, just a little bit about my background. As I said, we're going to talk through some ELK solutions as well as Docker, Kubernetes, and ECS. So in terms of the metadata that we're looking to capture, as we have our application containerized, the two common elements that we typically find are the environment, where is this coming from, test, pre-prod, dev, QA, etc., and what app or service am I actually looking to query logs or get some insight in. This information won't necessarily be logged by developers in the source of the log, but it'll actually be attached through the infrastructure as the log makes its way to the log aggregation solution. So some of the solutions we're after are looking to actually append this information to the log record so that we can make sense of it when we're running log analytics. The other thing that I'm looking for and when I'm having a specific problem and I'm trying to troubleshoot it is, what time did this actually occur? So if I can zero in on the environment, the app, the service, as well as the time frame, then I can get a lot better handle on troubleshooting things. So let's talk a little bit further about how we get all of those things into Logz.io or an aggregation solution. So this is just taking a look at an example record that we've sent to Logz.io, and you can see, this is in there as a field, environment is production, and the type is console server. So this is our end goal, is to actually get these into Logz.io and have them indexed on an individual field so we can utilize this for searching, visualizations, dashboards, and other elements of the troubleshooting exercise that we're looking to do. So we are going to recommend some best practices for a few different container logging solutions. We're going to be recommending some from FluentD, a few from the Beats family, and then Eric's going to talk through our different logging libraries around various coding languages. So those will be our best practice recommended solutions. There are other ways to log as well, and we're happy to assist with the configuration and guidance of those, but we do have best practice recommendations around all of these solutions where we're much stronger and where we have further documentation and further support for those solutions. So now I'm actually going to turn it over to Ido to cover ECS. Ido, if you want to go ahead and unmute. Yep. Ido, can you hear us?
Yeah.
All right, go
I can
ahead.
hear. Hey everyone, nice to meet you. Like Eli said, my name is Ido Levi. I'm working for Logz.io for almost 2 years, and now I'm like a product manager here, managing all the integrations. What we're gonna talk about right now is ECS. Two flavors of ECS. One is the regular one, and one is with the Fargate. We're using the integration that we have with ECS uses Filebeep. Okay, it's a native Elastic agent that knows how to send logs from files to Elastic, and we implemented a plugin for it that ships logs to Logz.io instead. What you can see here is just the diagram that shows how ECS are related to each other, all the objects, and the example of a stack trace that we would like to ship to Logz.io. Okay, so the main emphasis that we're trying to put in Logz.io is try to make the integrations as simple as possible. Okay, and when I added this slide, I just wanted to have that in mind. When you see what you see here is basically all you need to integrate with your ECS and ship those logs to Logz.io. Basically, you just need to pull a Docker that we already built for you, and then just configure a few parameters like your token and your listener URL. The rest of it is done for you. You don't need to do anything else. It will automatically recognize all your Docker logs and just pull them and send them to Logz.io. That's the regular flavor. On the next slide, you will see the what we recommend to do with ECS, with Fargate, sorry. Okay, so Fargate is, I won't say new, it's probably less than a year since AWS released it. And currently, the problem that we have with the previous integration on ECS Fargate is that Fargate doesn't allow you to run containers. That you can't mount volumes on Fargate, okay, to the host. If you saw in the previous slides, we had to mount some volumes, and Fargate doesn't allow you that. So instead, what Fargate has is log drivers, okay? Currently support AWS log drivers, which means that every log that the container will put out to the STD out will automatically be shipped to CloudWatch, okay? From CloudWatch, what we're gonna do is just use the Lambda that we already have. It's just a Lambda shipper that waits for CloudWatch logs, and every time it gets a batch of logs and ships it to Logz.io. If you'll take a look at ECS roadmap, you'll see that they are planning on implementing more drivers, just not at the moment. Once they're gonna have Fluentbit or Fluentd or even our own log driver that we built for Docker, then what you can do instead is just tell the Fargate to run with those specific load drivers, and it automatically will ship the logs to Logz.io. That's it, Eli. It's yours.
Thank you very much, Ido. Appreciate it. Eric, if you can go ahead and unmute yourself and then talk through how we do container logging at Logz.io.
All right, yeah. Hey everyone, my name's Eric Alfano. I'm on the tech ops production side of things, and I want to talk to you about how we log ourselves at Logz.io and ship the logs to ourselves. We obviously use our own platform and generate a pretty big amount of logs. So our logging now has kind of changed since a couple of years ago. We were more instance based and running things directly in VMs, where we would log everything to the host and then run a single shipping service like Filebeep, which would collect everything on that host and send it to Logz.io. Now we're much more Dockerized and running tons of things in Kubernetes. So that whole shipping architecture has changed a bit over time. A bit about our CI/CD. We use Jenkins for building our application, and Apollo, which is something we wrote for deployments, which gave a lot more functionality than you were able to with Kubernetes, especially at the time. And we later open sourced Apollo. So we use that for deployments, and then we use Puppet for configuration management as well. Could you switch slides, Eli? All right, thanks. So our application logging, we use Java very heavily. And so all of that logging is done through an appender, the logback appender. And what this is doing as an appender is it's shipping directly in the code rather than something where, say, it's logged a file and then collected later on by a Beats agent or our syslog or something like that. There's although this is the Java logback appender, there's many other ones as well you can see on the left, and there's even much more than that. We also use the Python appender in-house and some other ones as well. You can find all of these on either the log shipping page or docs.logz.io. And it's always kind of changing and adding more things, so it's worth checking out. So you can see here there's some different fields. There's in the deployment YAML, you can see the environment variables, which we then pass to the shipping side of things. The Logz.io token and the listener URL, you saw those earlier in Ito's slide. They're used for every shipping mechanism. That's what gets the logs to the right region for you, where your account lives, and into your actual account. But that's not enough to just send the logs. We rely on other metadata as well, things like the environment, the region. They're all crucial for troubleshooting issues and for alerting and things like that. So this is how we have those defined in the deployment YAML, and then have it sent through the additional fields option on the logback appender. You can also add all sorts of stuff. It just depends on your application. But in this example, those are the 4 additional fields that we have. All right, next slide, Eli. Thanks. So for per host logging, we actually use Filebeep in a Docker container. So we no longer run it directly on the host itself, and there's a bunch of advantages to that, obviously. So with that Filebeep container, we actually have the registry and the logging files mapped outside of the container, so it can be restarted and such, and continue to take off from the offset of where the last logs that were shipped were sent. And so some cases we have applications running directly on the VM, so like Elasticsearch, that's not something we're running in a container. Apache Kafka Zookeeper is very disk heavy. It's not something we run in a container, although much of our application and our services do. And so in those cases, it's good to have Filebeep collecting those logs. Another example is things like kernel messages, which aren't being sent by the logback appender, and those are gathered here through Filebeep. So this is similar to the logback appender, where on the Filebeep YAML you define different environment variables, different metadata, and so it's something that's very lightweight. It's using the like a very efficient protocol at the network level, and it is encrypted end to end. So it's one of the main shippers that we recommend. All right, next slide, Eli. So this is just to show you an example, kind of like what Eli showed before, but showing you those metadata fields in the log as they're populated. So you can see the region, the name, things of that nature. Okay, and this slide's showing, in some cases, we're sending metrics as logs to Logz.io, and obviously Kibana is not typically a metrics platform in the same way as Grafana or something, but these aren't things like CPU and RAM. This is more of like rate of services or latency between different components in the infrastructure, things of that nature, where it is very helpful to visualize on Kibana and send as log messages. Maybe a bit outside the scope of the webinar, but we also have metrics we're sending to Grafana using various metrics containers, like JMX metrics we send from our Java apps, Collectd-based container we're sending our host metrics with. And we have a metrics product that's in beta right now, which has some like JMX to Logz.io shipping containers and things of that nature for getting metrics out and into Grafana. So where does all this metadata come from that we're shipping and that's so crucial? It comes from a few different places. The Puppet Hyra, that's how we're structuring our Puppet that we use for configuration management. The AWS tags as well, they flow down into the instance using Factor. So roles and regions and the environment, all of that is stored on AWS tags for instances. And then on Kubernetes, we went over that in an earlier slide where it's defined in the YAML. And so they, as this is saying, they trickle down into the pod and container level. So for example, if it's a Kubernetes worker that's tagged, it's running Puppet and Factor, and that same metadata is available within the containers themselves. So some of the uses of metadata, not just in Logz.io, not just in Kibana, but we also use it very heavily for like our monitoring tools and alerting, and configuration management, but very much in troubleshooting issues and filtering by particular regions, particular instances, or the application name, things of that nature.
All right, Eric, thank you very much. Awesome. Thank you for explaining how we do logging at Logz.io. Ido, if you would like to come back off of mute, talk through our best practices or recommendations around Kubernetes.
Yeah, sure.
Awesome.
So what you saw in the previous slides was how we use Filebeep with Kubernetes. I'm going to show you now how we're going to use Fluentd. Both of them are pretty popular open source agents that you can utilize to ship logs into Logz.io. Eli, can you go to the next slide? Okay, so again, what we're trying to emphasize on most of the integration is just the user experience and just making sure that it's just a copy paste and you don't need to worry too much about how to handle the integration. Okay, so what you see here is the simple steps on how to deploy the daemon set that we configured for you. We already built the container, the Docker container that will run and just collect your logs. You have two parameters that you need to adjust. One of them is the token and the other one is the host. You can have other parameters if you want, but they are not necessary, they are not required. Okay, so you create just a secret key and then you deploy the daemon set. And basically that's all you need. You don't need to know too much about the details inside, although you can. Everything is in public GitHub repositories. but we're just trying to make sure that it's more like one click and that's it, and you see the logs. Okay, so this is how simple it is.
All right, Ido. Thank you very much for describing the Kubernetes solution. Appreciate it. I'm now going to go over some of the different options that we have and kind of comparison chart of each. So as I mentioned, there are multiple different ways to ship logs to Logz.io and to aggregation solutions. Eric talked through using some of the logging libraries, be passing most of those metadata information through with environment variables. It's a little bit more of a simplistic, the simplicity is leaves a little bit to be desired with the logging libraries, but it does have a good extensibility option for adding all of those different variables. And then not as good on the community support. FluentBit is also an option. How some of our customers are using FluentBit now is to actually send it to the FluentD aggregator first, and then utilizing the Logz.io FluentD plugin to ship to Logz.io. However, Ido and team are working on a FluentBit directly to Logz.io integration and plugin, and that should be coming very soon. The metadata can be passed through utilizing the FluentD aggregation. We didn't find as good of an ECS metadata solution there, and for Kubernetes, it's native for passing through a lot of that information. With regards to stack traces and multi-line things that requires a little bit of custom regex, it's relatively simple to set up a FluentBit, not quite as extensible as maybe utilizing FluentD. In terms of FluentD, we've tested this solution for Docker, for Kubernetes, and for ECS with all of the metadata. We actually have a plugin that you can run that we've tested and utilized. There's an open source plugin for FluentD to handle stack traces of a variety of different languages. FluentD is quite extensible. I would say maybe not quite as simple, but we have several examples to do that, and the community support is very wide for that. Finally, with Filebeep, we've tested several of these solutions except for the ECS. You do have to write some custom regex for handling the stack traces and things. It's very simple to set up Filebeep to capture this information. We walked through a few examples earlier with Ido. It's not nearly as extensible as the FluentD family, and it has pretty decent support across the community. So our general best practices and recommendations here are to run the collector container as a sidecar, and this is, whether you're going with Filebeep or FluentD, it maps through and uses a volume mount to capture that information from the actual host level. This is, again, along the same lines as why we have a particular issue in doing that with the Fargate solution. We don't have access to mount volumes to the host, but that's in general the best practices we found for pulling that type of information regardless of which collector you are using. Our other best practice recommendation, which sometimes end up being a bit cultural as well as technical, is logging in JSON at the source, right? If you log in JSON, you have full control over all the fields and all the updates, and then it will be parsed automatically by Logz.io or any other log aggregation solution, which is Elasticsearch based. We find it's best to use the default Docker logging driver, the JSON one. The reason for this is you can run a quick view on the logs even outside of the log aggregation solution, as that data will still exist on the host as well as across whatever log aggregation solution that you're using. Finally is to log to standard out. This is excluding the logging library situation where you would log specifically using the logging libraries. But again, we find that it's very simple for developers to just log to standard out and then have that information picked up by the Docker logging driver. Here's an example of something you may build around containers once you get all that metadata in there and properly parsed. You can build aggregations taking a look at log levels, different container images where you have issues, response time, as well as the different service that you may be potentially finding. We find that it's very good to put a log search on a dashboard as well, allowing you to do very simple drill down and filter in order to view the logs in a little bit more detail. Finally, this is our reference architecture for various links with FluentBit, FluentD, and Filebeep. This is subject to further updates. We also keep the log shipping documentation within the application itself up to date, and we have the docs at Logz.io as well to explain how to do this further. And feel free to shoot us any questions as well. Finally, summing it up here. There's a link to our blog. We have a complete guide on running Elasticsearch log session containers, as well as the Elastic docs themselves. Awesome. So feel free to shoot any questions into the chat at this time. I'll go ahead and wait just a couple of minutes in wrapping up here and answering any questions. And I think we'll kind of end at the half hour unless there are further questions that the team should elaborate on. Feel free to direct any questions to myself or Ido or Eric. And Eric and Ido, thanks again for participating from the product management as well as the tech ops side of the house. Anybody's welcome with questions if they want to type them into the chat, which I'm monitoring, and I'll go ahead and address those. We'll wait probably just one more minute if there are no questions at this time. Also wanted to mention, if you wish to sign up for a Logz.io free trial, www.Logz.io, you can just click the free trial button there. You can ship us some data. We also have some sample data that you can even load into the platform and just get a further feel for the platform if Logz.io is a new solution for you. All right, I'd like to thank everybody for joining today's webinar. I hope you enjoyed it, and thank you very much. Bye-bye.